Thank you, gentlemen and ladies. I'm Dennis Boley. A little bit about me. I've been around a long time. I'm a graduate engineer from Georgia Tech. I have a master's degree from there in 1977. Don't hold that against me if any of you guys are from Georgia. I worked in the foundation and ground improvement business my whole career. I started out first working in the nuclear industry doing power plant sightings, and then progressed to doing design, build, construction, and found that to be extremely rewarding. Most of my career has been spent as a fix-it guy. And as a youth, and getting interested in engineering and building, I built homes with my grandfather to help put myself in college. So my interest started through him, and then, as it turns out, you usually find a mentor, and so I got involved in the geotechnical business. The company Gibson Grouting has been in Atlanta since 1985, incorporated in 1985. We work primarily from the ground surface down, doing ground improvement through various types of grout injection, including cement grouts, chemical grouts, cellular grouts. And we also do foundation underpinning and repair with helical piles, dribble grouted mini piles, that type of thing. As well as, we mentioned the wall repairs, again, tiebacks, that type of thing. So, in summary, what I do is primarily from the ground surface down. And it impacts, and why I've been asked to come here and talk to you is the one thing that you guys will see oftentimes, particularly in the Atlanta area, has to do with foundation problems and the world that we live in here. It's very easy to have foundation problems in Atlanta with the Ridge and Valley geology that we have. And so I'm hoping that as I go along here, I'll see some examples of situations that you've run into, things that you might look for when you're doing your inspections about whether they might have a foundation problem or not, or whether they could have shortly, depending on how new or old the house is, and what solution you might have to recommend to them to make that repair. So let me get on with it here, and as we do this, if you have questions at the time, ask, or if you have some input that you'd like to have asked. I'm doing this primarily as a learning experience for all you guys. So if you have a question then, it would probably be more beneficial for everybody if you're trying to think back what that slide might look like. In residential and even in the commercial and industrial arena, you're going to have typical types of foundation problems that you guys are going to run into on a regular basis. And they're the kind of things that trigger work for guys like me to do. Oftentimes, poorly compacted soils, fills that were put in place to build this new house, slopes that are unstable because of the geology and because of potential new construction fills that they put there. You might have inadequate foundations. Common, believe it or not, even under new construction, the foundation just got slipshod. Unstable walls, I mentioned it before. Most of those happen to be, in this day and age, they happen to be those old timber retaining walls that have been in existence now for 20 years or more, and they have reached their life expectancy. So now what do you do with it? Those are real problems. Excavations, not so much maybe, but the other one that's a big one that you probably see it often is improper drainage. I want to go through some examples here of some of those types of problems. Oops, pushed the wrong button, that's why it's not working. This happens to be a cartoon for purposes that I've made here. It could right now it looks like a bridge above it too, but it could very well be a house, very well be a basement for a house and a garage. And what typically happens in the Atlanta area, since we have a lot of that Ridge and Valley, we're building houses on the side of a slope, we'll have a large portion of uncompacted soil here, right up against that basement wall that the builders don't like to have compaction equipment against. So routinely they're just shove that material in there and it settles. And it gets worse if there's things like water lines or sewer lines that happen to be in this fill, and they're transitioning from a soft material, a poor fill, to a hard material, in situ soil or rock, and they break, they snap, and they create an environmental issue, and also a trigger that causes this settlement to get even worse, it magnifies it. So one of the things that has to be done here is we need to fill the void, but we also need to treat these soils. Put material in here, typically a grout material, and here's where I'll mention what I mean by grout. I mean a mixture of cement and water, possibly an additive. Recently, we in our profession are doing a lot of what we use as cellular grout, which happens to be a mixture of neat cement, bagged Portland cement, 5 gallons of water, and then 4 cubic feet of a cellular foam all mixed together. That original unit weight of cement and water is on the order of 114 to 115 pounds per cubic foot. The cellular grout is on the order of 40 pounds per cubic foot. And it has a unconfined compressive strength of 28 days of 100 psi minimum. So it's lighter, it's stronger, and it allows you, in a situation like this, if you had, say, some type of sewer in here, you could come back later and dig it up. You can dig it with a shovel, just like dirt. Okay? But just filling the void isn't the solution either. You have to stop the problem originating, poorly compacted soils. So what we do is we drive grout injection pipes on a grid type pattern, typically on 5-foot centers, and we drive those pipes down to competent material here, and then we inject grout as we pull those pipes back out of the ground. Doing 2 things. One, treating the soil, i.e. compacting it in place, if you want to think of it in those terms, or creating a composite structure of grout and soil that won't settle again. And we also have the void fill. Yes, sir.
Now, what would something about that typically cost?
Well, and obviously it depends on how big the job is, but you might, as an example, you might have the neat cement grout might be on the order of like $200 a yard if you provide that material, whereas the cellular grout's going to be half that per yard. Depending on how big the job might be, typically jobs in the residential arena are small one-day jobs, typically like a garage like that. And so you're looking at what the crew costs and some nominal material costs. Might be under $3,000. Okay.
Considering that foundation wall, do you all do any pressure measurements on that wall with the pressure grinder, or is that something that...
Legitimate question, I'm glad you asked it. In this example right here, you see some type of a dial gauge, that's what that's supposed to represent, against the wall to see if there's a pressure buildup. And I'm going to make 2 statements about grouting against retaining walls. Many times, the older the house, particularly in the Atlanta area, the block wall is the basement. And they can't take much lateral pressure. The more newer walls, we're going to use poured walls, work much better, but still, people don't like to compact against them. So what we have done is we have 2 types of grouting that one can use to compact soils like this. One is what we call a low pressure system, where we use grout pressures that are only on the order of a maximum of 50 psi, versus another type where we inject a very stiff Anyway, the other type of grouting that we use is known as compaction grouting. It's typically used in the geology known as karst geology. Where you guys would run into that would be in North Georgia, places like Rome, Calhoun, Gordon County, where the karst topography, which is limestone in generation, where the reason you have the sinkholes and the caves and the waterfalls that you see in Tennessee, That geology runs from basically, can you tell that? Thank you. That geology is sinkhole country, and it is a different type of grouting process in order to treat those kinds of soils. Okay? Those pressures, injection pressures, are on the order of 300 psi. Okay? So, yes, I put those pipes in on an 8-foot center spacing typically, and we inject the grout into the ground. It looks very stiff like a mortar. In a concrete test, if you're familiar with slump tests, it will be on the order of a 0 slump to a maximum of 5-inch slump. And we force that into the ground. It's a mixture of sand, cement, and fly ash and water. Under high pressure, making a ball and compacting the soils and filling very large voids that you typically encounter in that karst-type topography. We don't get close to retaining walls like this with a high pressure grouting any closer than 8 feet. Okay? In the residential arena here, where we have very shallow heights, these heights here are on the order of 10 feet, let's say. The karst topographies are on the order of hundreds of feet.
So your objective is not to raise the slab, it's to stabilize it.
That is correct. My objective, first and foremost, is to treat these soils so that they never settle again ever. Then we deal with the slab. And we can either try to raise it by pumping the grout in here and raising it, or we just plain have to put an overlay on it or whatever. And that becomes a function. When do you do that? That becomes a function of how old the slab is and how broken up the slab is. If it's all broken up, I can't raise up a bunch of cracks. It's just going to fall apart. The other thing that you have to remember when you think about wanting to raise a slab is that raising any type of a structure, be it a slab or be it an entire building, because I've raised entire buildings also, they work like a car door. You can open and close your car doors many times as you want until you put something in the jam. And as soon as you have something in the jam and you try to close that door, what happens? Collateral damage. Something starts breaking. Something gets bound. So if this slab is bound in any way and you try to pressurize it, you're going to break it. And you will cause more damage than if you'd have just left it there or taken it out, but left it there and put a topping on it. So it's not just something as simple as mud jacking the slab. Okay? So the pressures that we're using in the residential arena are very small pressures. If we have a 50 psi, we don't inject any grout. If we get to 50, we just stop. That means the soil's already hard enough. Doesn't need to be fixed. That's right. I feel loose soil, so I'm putting grout in the ground. If I only have 0 to 15 psi of pressure, I'll put 3 cubic feet in a 1-foot lift. I'll raise this pipe up 1 foot. I'll start to inject the grout and I will monitor the pressure. If it's between 0 and 15, I'll put 3 cubic feet in that stage, and then I'll raise the pipe again. I'm trying to control pressures, I'm trying to control the amount of grout that I use, and I'm trying not to cause undue pressures on the wall that's currently okay. So all things that we've developed over time. Okay? Anybody else? This is just more of a cartoon demonstrating as we lift the pipe out of the ground, we inject the soils and grout here and densify, and so we're improving the soil so that I don't have a problem. That's the objective. We're done. I don't have do-overs. I don't have a redo crew that comes in after the first group. We're done, and we're done. And you know where that is. Basically, one big footing. Yep. One big footing. This, we refer to it as low pressure grouting, but let's talk about some words you might have also heard in the workplace out there. We're doing ground improvement, ground treatment. There's a number of things that you've probably heard or read that you can use to improve the ground. You've probably heard of stone columns. Yes? No? Are you familiar with a company known as Geopier? They drill a hole, they dump gravel, and they compact that gravel. Instead of having grout here, they have a large diameter pile of gravel. that they put in there and compact it into ground and create a composite structure of stone and soil to build a footing on top of. That work is mostly done on new construction. Remember, I'm the guy that's the fix-it guy. I'm not tearing down this building to fix the ground. So I don't have the ability to use huge equipment. My equipment is the kind of stuff I can carry in there, drive in there. I can work in low overheads and tight quarters. Okay? So there's other things you might have heard. Chemical grouting, polyurethane grouts. Also works, but you need a particular type of soil to utilize that type of material. It's a function of soil type, grain size. As an example, you're not going to use chemical grouts, polyurethanes, in cohesive soils, clays. Don't work. They don't work. Okay? So there's a reason why you choose the type of grouting or the type of soil improvement technology that you're going to use. And it has a great deal to do with geometry and also the type of soil. If you were to see in plan what that would look like, you see the ground injection locations on a given pattern, and that's typically what it looks like. It's not rocket science, but we've developed techniques to get what you need to improve those soils so those foundations don't move any longer. Now, where might you find situations like that in the Atlanta area? Here's a brand new house. Oops. Here's a brand new house. Side hill situation. The basement, the basement floor is right here. Okay? The street at the front of the house is roughly this level. Okay? This is all soil. Do you think that they used a lot of compaction against that brick wall and block wall? No, they didn't. There's a whole, I'll show you some more pictures here. A string of homes, all built the same way, in the same location, all with their basements founded on fill. And what's the next thing that typically happens with those basement slabs on fills like that? They start to settle, but what else happens? They have load-bearing walls on those slabs typically, and those load-bearing walls that settle, and you guys, when you go do your inspection, you see in the wall cracks. You see 45-degree angles going up against the side of door openings. You see door jambs that aren't square anymore. Those are the reasons why. That right there is a ground improvement project that we did for one of the local home builders here in Atlanta. We had grouted one of those new buildings because they started to sell. Here's another, I don't know if you remember, Richard, this is the Hahn Mansion here in Atlanta. I pointed this one out to you because these foundations, or these columns in the original design, were to be made out of timber and made to look like sandstone columns. But the owner decided he didn't like the way those looked, so he decided to put true to form sandstone columns. And he didn't change the footings. So every one of these footings was designed to support a timber column, and there was no real load here on this roof. There's not much load there for that. But that sandstone column is significantly higher. You end up having to fix the foundation in order to support the column. In this instance, we use a combination of grouting and helical piles to support the foundation. Now, here might be a more common situation that you guys run into on a regular basis, because it happens to be a combination of things. Excuse me, a combination of things in the residential arena here. On the side of the hill, and a house with a basement. There's a daylight basement here. So you got a basement wall, the top of the basement wall is roughly right here. Here's your first floor. We've got a retaining wall, one of those nice timber retaining walls that we were talking about a minute ago. have a stoop. Here's your basement wall, here's all backfill. All the way through here, which they built this stoop on, and you can see where it's moving. See where it's pulling away from the house. A very common problem. Soil's there, we're not compacted, it's up against the basement wall, so you have to make a repair. We can grout it, we can put helical piles on to lift it up and support it. Typical problem here in town.
Sounds about the drainage, it helped them out.
That's exactly right. One of the other things that you will often see, I'm sure you often see it, is keep pushing the wrong button. That situation right there is really prevalent in the Atlanta area, and I don't know why it is, but they always put the downspout right where the thickest amount of soil is. I don't know why that works out that way. It's routine. I'll show you some pictures later on of those kind of drainage issues that I'm sure you guys run into on a daily basis. Other kind of triggering mechanisms that you're going to see that are going to jump out at you are block walls that are cracked. Typically, it's been my experience that when you're facing a settlement issue, the crack that you will find in a masonry wall, be it block or be it brick, typically is a stair step.
Right.
Okay? When it comes across the block and shares the block, you typically have something more than just a settlement problem. There's some other type of a structural issue here. Could be there's a roof rafter there. I don't know. I can't tell you. I don't remember. But it's these kind of telltale signs that you want to look for. Vertical drywall cracks above a door, like above that wall right there. If they were just vertical, they're not typically settlement problems. It's just a lousy taping. When you're finding that crack coming across the doorway at a 45-degree angle, something's settling, something's moving. It's caused it to rack. Okay? That is indicative of a settlement crack and a rotation of the footing. You can see it's rotated more than it's settled at that point. Why? Because the horizontal joints are still tight, but the vertical ones are open. Inadequate foundations. It's been our experience in working in the residential arena here in town, is that we can find a multitude of foundations that are unbelievable. And here's one that you guys may or may not run into. As you can see, this deck is supported on these nice little posts. It's a multi-story deck. The hot tub's got something going on here. It looks like a turned over cinder block with some type of a post in the center of it. But what's even more important to me, I don't know if you noticed it, is here's a concrete floor. And that wall right there is a timber wall. Here's another view of it from the side. This is a concrete floor for the first floor of the porch deck, whatever you would call it. And this whole foundation is a timber wall. Designed, like I said before, a maximum of 20 years. And this one looks like it's well on its way to reaching 20. Or you can go in basements in some of these homes, particularly some of the older ones, and you'll find that they drain into something that was a little too hard to excavate. Are you guys familiar with the term PWR here in town, partially weathered rock? We have a geology here in town, if you're not familiar with it, where you see that nice rock out there at Stone Mountain. That's our bedrock, typically in the Atlanta area. And as it weathers, it weathers into soil. And we call partially weathered rock is when you can still see what looks to be rock. What we call the fabric of the rock, but it's soil. It's hard soil, mind you, because if you're familiar with geotechnical terms, that partially weathered rock may have a standard penetration resistance of 50 or more blows per foot. Okay? or refusal, couldn't drive it at all, couldn't even drill through it. That's how hard it might be. So you'll sometimes find where they've come in, they've jerry-rigged their footing because they just plain couldn't dig anymore, and sometimes you're gonna find that they just plain didn't do it because they didn't want to do it.
Another example.
I'm talking about right here. There isn't even footing, there's just blocks sitting on top of this material. Here's a residence in one of the older neighborhoods in Atlanta. You may or may not run into this very often, but you can see this basement wall here is all laid up granite stones. And they're having a settlement issue. They had some drainage issues. They had a settlement issue. It's on this corner of the house. So they wanted us to underpin that home to hold it up and then fix the cracks, etc. So in order to use any type of an underpinning foundation, be it a helical pile, a drilled and graded mini pile, a push pile, whatever, any one of the mechanisms that exists out there in the world, you have to have a foundation to latch onto. In this instance, there is no foundation. The blocks just went down, the laid up stones just went down to where they went to, and they stopped, and we could still dig beyond that. That little device right there is nothing more than a tile probe we pushed into the handle right below that. So it's just there where it is. And so we have to build a new foundation, tie this to it, so we can then put the underpinning pile on it to support it. Yes, sir.
How common is that?
How common is it?
How common is it to have either just a nominal course of mortar before they lay the first course of stone, or nothing at all in a 70-year-old granite
In
foundation?
older buildings like that, it's very common.
Very common.
Very common.
Okay.
Very common.
No footings at all.
No, sir, no footing at all. And here's the other thing that comes into play too. I'm often asked, I come to a house that's, well, let me step back. I'll make a statement to you. This is experience on my part for 40 years of work. In the greater Atlanta area, you can count on the settlement of a structure, the biggest magnitude of it taking place in the first 5 years of its life. Okay? After that, it will continue to settle, but the settlement rate will slow down with time. And typically, by the time you reach 20 years, it's not going to settle anymore. Why? Because it's reached its state of equilibrium. It's like a sponge. You can put a weight on a sponge, and you push on it, and it'll stay right there until you increase the weight. Then what happens? It goes down some more. The caveat to my statement is this. There is one other thing that can cause that 20-year-old house to settle some more, and that is a change in the environment, which typically happens because a water line broke, a sewer line broke, are the two most common reasons. But there could be other reasons. Somebody was digging around and put something else in here, and now it weighs more than it used to, so something starts to move. So when you're looking at properties like this, and you happen to see that there are some cracks in this masonry, and this house is 30 years old, and are you expecting that it's going to settle anymore? You're going to look for the things that caused it that would cause it to move from here on out. Okay? Or if you have to fix it, you might as well figure if it's as old as that house I just showed you, it probably doesn't have a footing under it. And something has happened to change that environment. Yes, sir.
So as an inspector, if I see some foundation settlement, I just want to know, is it historic and stable, or is it dynamic? One thing I might do is look and see if they took out the old galvanized water line and replaced it with a PVC.
Yes, sir.
And that might be a surmise is that the movement has ceased because we took the water out of the equation.
Yes, yes. Or, I'll give you another example, the same thing. You happen to see some cracks in a particular area, and you happen to notice that there's a bathroom there. Or you happen to notice that the sewer line comes out there. The sewer lines, let's face it, guys, you and I both know it, they're kind of rigid typically. Even if in the latest day and age when we make them out of PVC, in the old days they might have been made out of cast iron. And so when you go from something that's moving to something that's rigid, you get a break there. If it just has a small crack in it and it starts flooding over time with that material, it just makes it saturated and the environment changes and the sponge takes on a different engineering characteristic and it typically results in silt. All of this is very, to me, is very common sense if you're looking for the telltale markings. And that's really what I'm trying to give for you guys here, is those kind of telltale markings that I've found over 40 years. Yes, sir.
Back to this example where there was no footing under the stone wall, do you undercut it and put the footing periodically down the wall, or how do you do that?
Yes, sir. We undercut it on roughly 4 to 5 foot spacings. Why is that spacing big? Because unreinforced concrete or unreinforced masonry can span roughly 4 feet, maybe 5 feet. So if you make a footing that's sufficient width, and then you put a helical pile or some type of a deep foundation in the center of that, the span between the edges of the footings can't exceed 4 feet. Otherwise, you got to do some type of reinforcing, and you're not going to reinforce an old granite wall like that. So you've got to let the engineering work. So you're going to end up underpinning something like that, and to do that, you're going to build a foundation. And I don't know whether I have a picture of this one in there, where we had to build foundations underneath there and actually try to dowel the blocks to them and cast around.
Is that just in the area of the ground, or did you go all the way around that?
In just this corner, they just were interested in this one corner. This is the other thing I'll point out to you. Good question. You made me think of something else. If I go back here, a couple of pictures. Here. This is one of the other things I want to point out to you. You see cracks right here that indicate that this wall is settled. It's been my experience also when you're having a settlement issue of the foundation itself, you will also find a corresponding crack on the other wall, or in this case on the face of the structure, the 90-degree corner, okay? And it indicates the footing has settled, as you see the corresponding crack. It's also been my experience that if it's moved enough, you're not only going to see it on the outside in the bricks, but you're also going to see things on the inside of the house that tell you that it's moved. You may not see a crack, you may see a bad plaster job. Or something's going to stick out at you, you'll see it. Okay? If you don't find that corresponding settlement crack on the other side, you need to do some more investigation. Oftentimes I have found, when I did not see that, and I saw the crack on one side of the building, and I didn't see anything inside the structure, what I really had was a brick ledge problem. It's not indicative of what we see in here, but you have a brick ledge problem with the bricks sitting on it. And the bricks on one side of the house let loose and the others didn't. So it wasn't a foundation failure per se. It was a brick ledge issue. Different mechanism to fix it. Yes, sir.
I found a lot of houses built in the 50s that crawl spaces with concrete mixture and blocks. Those bricks are on top, you'll see shear tip crack around the window. I don't see any water in the crawl space. The block below is not cracked. I just don't monitor it.
Yes, that's what I would advise them. A house that old, built in the 50s, same kind of thing. If the crawl space is dry, if the lay of the land is such that you don't see a mechanism where water's coming in. That's the other thing that I mentioned to you too. When I walk onto a job, I not only try to look at that problem, but I want to look at the lay of the land. What has changed here? Where's my biggest trees? Has this been a field put here, or is this natural soils that have been here? Has there been a new utility brought through here? Has there been a new house built? Is there something that has changed the environment because a 50s house to have a movement in it? Most likely that 50s house had that movement and it's been there for a long time. That's been my experience. Unless something changed the environment.
Just additional movement.
I'm sorry to repeat that.
Do you recommend repairing the cracks, any other airline cracks that you can tell us to move again after that?
There's two ways to do that. There's two ways to monitor. One is to put what we call a crack monitor in there. You can buy these little devices that look about like this thing here, and you glue two ends, one on one side of the crack and one on the other, and it has graduations so that you can measure, okay? And if you hold it rigid, it continues to move, and you can monitor that. You can also do it simply by just going to the store and buying yourself one of those plastic rulers and putting those on there and making some mark that you know where it is. So there's lots of ways that you can monitor that, but yes, you can do that. You could also patch it if you wanted to and see if it continues to open up. That's another way. But then you're going to have to repoint it again later if it's truly moving. So, yes. In the greater Atlanta area, particularly in the northern part of the city, we have some pretty nice homes being built, and they're typically built. And here's the other thing I want to point out, just remind me of something else. Recognize as you go to look at homes that the good lots have already been built on. They're the ones that have the 50-year-old houses. 1960s, maybe 1970s. The new ones that you're going to go inspect are built on the worst lots. They weren't buildable before because it's too expensive to build on, but now we are. We want them. We want to put people here. Here's an example of someone who wanted to terrace their slope by putting in timber retaining walls. That timber retaining wall isn't even 2 months old, I think, but it's already moving down the hill. So now you're the building inspector. You come out here, this person thinks they might want to buy that house, and we don't have all that plastic on there because this guy knows he's got a problem. He's trying to cover up his water problem and he's trying to save his wall a little bit. But you don't have that. What's your recommendation? That's a brand new timber wall. Tear it down. You got a problem, sir. Whatever you want to do, if you want to buy this house because you like it, just recognize that that's a problem. You're going to have to deal with it sooner or later. There's better picture. Look how steep that hill is. Was that an engineered wall? Sure. This engineer didn't engineer that wall, I can tell you that. I doubt that anybody engineered that wall. I think the landscaper was hired at the low price to build him some walls, and that's what he came up with.
Yeah, and it's all 4 foot.
You also will find some, this doesn't happen to be a residence, this is actually an apartment complex. There are a number of apartment complexes throughout the greater Atlanta area that have very, very tall retaining walls, and they build them all out of timber like this. This is a parking lot for the apartment complex up here. The only way to fix that wall, frankly, is to tie it back and then you have 2 choices. One, you can just put big plates on the front like shit. Or you put some type of a modular facing on the front of it, or some type of a concrete facing on it attached to the tiebacks. Okay? Because that has reached its design life. And that kind of a project requires some engineering evaluation to see how far back the tiebacks need to go, et cetera, et cetera. That's a big deal. If your customer has that kind of a wall, tell him to walk away no matter how much he likes the house, because that's more expensive to fix than his house is worth. Here's another common problem, not so much recently because of state laws, et cetera, that prevented it, but it was not uncommon for the builders, as you guys well know, to make nice excavated pits out in the yard somewhere, bury their trash when they were building the building. Sometimes you find, and this is hard to see, but this is a tree. These are trees, and this is a a single-story ranch house, and those trees went from one end of that 60-foot house to the other end of that 60-foot house, and it was the whole backyard. A trash pit typically around here is going to tend to be about 2 bucket widths wide on the backhoe. And it's going to be about 14 feet deep. Okay, they don't typically get deeper than that. They don't typically get wider than that, unless we got something like this going on. And how do you fix a trash pit? Well,
Dig it out, put it gravel.
that's correct. My first advice to anybody is dig it out. If it's too close to the structure and you can't dig it out, then we can attempt to grout it. I have grouted trash pits that were actually underneath homes, but I also put piles in to support them, were driven down through the trash to support the foundation, and we grouted the trash material itself. The problem with even trying to grout it is that you can't assure yourself that you're going to encapsulate all the timber. And if you can't encapsulate all the timber so that it can't be decomposed or eaten by the termite population, then it's going to continue to move. Okay, so always, my advice is always to dig it up. And now typically we find these kind of things are mostly underneath driveways, maybe out in the guy's yard. I got one at my house. It sits out in the back, and I watch the dirt go down, and I suppose I'll have to go buy some more dirt and put over it because it only grows grass. But if there were a structure, we'd have a big problem. Okay? So when you're, why I bring it up, if you happen to see in your inspections that I've got a building here that's got this crack on it, but I see this linear little thing that's coming out away from the building, my guess is it's one of two things. It's either utilities that are coming in and out of the house that somebody didn't do the trench right, or it's a trash pit. And you need to investigate that to see what it is. But they're all, it's been my experience, they're easy to identify. They're pretty regular in their geometry. Improper drainage, this is probably the thing that you guys probably see the most of, I guess. Surprisingly, you do a terrible job of taking care of the drainage. I apologize if this picture was a whole lot better than the light, but this is underneath the deck. Overhead, the water is going back, the drainage is all going back towards the house instead of away from the house. These are all mechanisms that can easily be fixed, but they also cause other problems to happen, like settlement. So not only do you have to fix the foundation now, but now you've also got to fix the drainage. Poor drainage. This happens to be in the basement. It's hard for me to believe that people can let things get that bad, but they do. They're easy for you to find when they let them get that bad. But notice all the bricks and everything that are screwed up because of this drainage issue. Okay, so I've already mentioned some of the ways that we can, some of the techniques that exist out there to try to fix these problems that you're going to encounter. I don't suppose that you guys do. Maybe you do. I don't know whether your customer asks you, how do I fix this, and who do I call to fix this. If they do, here's some potential things that you can put in your arsenal. The issues of helical piles, drilled and grouted mini piles, or pressure grouting. Three kinds of things that my company typically does, and we've fostered here in town since 1985. And I'll run through these quickly. I'm sure you guys have probably seen them, but this is a helical pile installation, a typical helical pile installation. You can see the piles here going into the structure on an orderly fashion, typically on the order of 5-foot center to center. They can be wider if you got a better foundation, and it can take the load. It's all a function of design and how good the footing is to span between the piles, or how good the material is that you put the pile in to support the piles. for the building. Because remember, helical tiles are like a wood screw. If you put a wood screw in balsa wood and try to pull it out, it comes out relatively easy. You believe that? If you put it in red oak, it don't come out so easy. So we're trying to put helical tiles in the red oak, not balsa wood. But if there's no balsa wood present, or no red oak present, we have to use balsa wood, and therefore those tiles are going to be longer. They're going to have more helices on them, more screw on them, so that the load gets transferred and you don't have as high a bearing element on each shaft. You understand that? The problem that we have in the residential business, though, is that we now don't typically get a geotechnical engineering report. Because you have a problem with your house, and it's your house. And I don't have big, deep pockets, at least maybe you do, but I don't. So I can't afford to have this guy come out here and do a whole bunch of engineering, drilling, and evaluations, and all that kind of stuff. So I just call up this guy who's been in business since 1984. He must know what's going on. And so we do tend to learn what's going on. We happen to be familiar with the area. We know the piles in this area are going to go really deep. And so I'm telling them. Now my competition didn't know that, and they tell them something different, but eventually they'll pay for it one way or the other. Or I'll know that by looking at the lay of the land, these piles are only going to go 30 feet, because right down there is a creek. And all of this dirt was put in here to build this house, and it's all 30 feet thick. You can guarantee those piles are going to go down to the natural soils.
You have the price per foot.
Typically, yes. I'll typically give them a minimum price for a pile that's 20 feet long. If it goes deeper than that, this is what it costs you per foot beyond that. You'll find helical piles, if you're not familiar with it, might have various shaft geometries. That there happens to be an 1 3/4 high-strength steel shaft. And I particularly like those because I can grout those also. So it makes them even more rigid and more lateral resistance for the shaft. But there's a lot of them in town now that are being done with pipes of various sizes, from 3 inches to 3.5 inches. And that's a common. The foundation brackets, I didn't show the first one. This is another option. This particular, this is your helical pile shaft, that's the pipe. But what we're doing here is we're building a bracket. We're drilling into the existing foundation, and we're going to construct a reinforced concrete bracket to use for this pile. Not done very often. This had to be done because the loads on the pile were higher than the bracket would be able to take, a standard steel bracket. As you can see, engineered design, we got rebar going in. Here's rebar, here's your pile shaft. Now we'll pour concrete around that and make the bracket.
And that's epoxy that I see coming on.
Yeah, the epoxy, the rebars into the foundation so that we can get the resistance we needed on it. We had rebar that went in, and we had rebar that came out and up underneath to make a box. See it here? And then this was all then poured in concrete. I think I have a picture of that here in a minute. That happened to be on a building that was an institutional building that had undergone settlements of such a magnitude that we had openings like this in the top floors of the building.
Question.
Yes, sir.
You, screw the helicals, do you put pressure gauges on there to see how much?
Yeah.
Square foot you're
Yes.
jacking?
How the helical pile works is the industry has done a good job of technically and engineering and preparing how to use these devices. And what we're doing is that we are twisting it into the ground with hydraulic torque, and we monitor the torque that we are getting. And we know through tests that depending on if that's a pipe shaft or a square steel shaft, if we get a certain amount of torque, a certain amount of foot-pounds of torque, we will get a certain amount of end-bearing capacity. Okay? I can then increase the capacity of the pile by grouting the shaft below ground. Not typically done with the pipe piles, but I can do it with the square piles because I can put a little device on it that allows the grout to be pulled down with it. Can you picture that? You just keep the hole filled with grout and I can pull the grout down with it. So now, on that particular type of a pile, I not only have end bearing, but I've also got some side friction that I can count on. Okay? All engineering design. And when you have someone put those in for you, you should ask for a report for it. You can get a report of the torque that went into these piles, how deep they went, etc. They're not going to give it to you. I don't give it to you unless you ask for it. I got it. That's how we determine what we're going to have to do. But you can get a report of that. You'll know exactly. Yes.
Just roughly, I came across a house that had like 21 of those. And I asked the question, hey, how much would something like that cost? And no one ever would give me the information.
I'll give you my rule of thumb.
Yes,
If you want to know how much a helical pile will cost, use $100 a lineal foot. Okay? So that 20-foot long pile.
so there's 21 of them around the house, so,
Yeah,
so each one's 20
$100
foot.
a lineal foot in place. And you'll be covered. Could be less than that. Could be more than that, depending on access, problems, debris, whatever you might encounter. There's kind of things to change that. But if someone wants to know, I just look at it and say, $100 a lineal foot in place. Yeah.
So that concrete bracket that you made, how do you jack that?
Let me see if I actually have a picture of that. Let me go back. You see, let me go back one more. You see this sleeve right here? That sleeve has the pipe in it. Okay? And so it's used as a bond breaker. So when I cast the concrete around here, I got concrete up against this surface, but it's not going to bond to it because I've used that PVC. It's a bond breaker. And then I'll go to the next picture. See this plate right here? That plate is where the jack sits. And I put another extension of these two threaded bar up in the air, put the jack in there, and put another bracket across the top and jack it. And that pushes down on the pipe. It pushes down on that pipe right there and pulls up on the foundation. Okay?
It's got a through bolt that goes in there after you get it where you want it.
Yes. Yes. Here might be one of your typical foundation brackets as you would find in the industry, just a normal residential. Here's a normal residential bracket. This one right here is more of a commercial bracket. One of the particular suppliers. Those brackets right there are 100 kip capacity, 1,000-pound capacity brackets. Yes. Sometimes we get foundations that might be block, or might be concrete, but they're not sufficient thickness enough, or the bottom of it is so bad that I can't get the bracket in there without doing excessive trimming, and then I'm going to start taking away meat on the foundation. And so sometimes we end up making our own foundation below that, in which we put the helical pile attached to. Doesn't happen often. Typically happens when we have higher loads that we're working on, and we need to spread out the piles more than you would normally do, because all becomes a cost juggling act. It's cheaper to make the foundations bigger than it is to put more piles in at $100 a foot. So you end up with a foundation that has a bracket on it then. Lifts the foundation up, and the nose, typically on these also, because it's so big and it's away from the foundation, it helps work like a lever arm. We can help raise the building. Picture that? Yes, sir.
Over time, do you treat that so that you don't get corrosion?
Yes. This right here is galvanized steel, this right here is reinforced concrete, and that right there is all galvanized steel.
Okay.
And then, I mentioned, somebody asked me a question, I said we will grout some of these. You see that opening right there? Most of the industry will never tell you this, but I'm going to tell you this. When you screw that pile into the ground, there's always an annulus around the shaft. And if you look in the information that you're going to read online to find out about these piles and everything, everybody's talking about unsupported links, and don't worry about it because the soils are right tight up against it. When we're in these soils in the Piedmont, you're going to find that you have an opening around that shaft. And that's why I like to grout it, because now I not only my lateral support, I've also greatly increased the capacity of it. Okay? But you're never going to find anybody to tell you that. I'm the only person going to tell you that.
How long does the concrete set before you can put the pressure on?
Typically, that kind of thing is going to set for, well, if I have to jack and re-level the building, then I'm going to wait till I get a compressive strength break that's on the order of 2,500 minimum PSI. If I'm just tightening up, taking the slack out of the elasticity out of the pile, I might do it within a day or so. Okay. Because there's some times that we don't try to raise that building because of the car door thing I told you. It's just not going to work. So we're going to put this pile in, and we're going to put enough load on the foundation to take the elasticity out of the steel pile. Okay. So now we've put load on it, but it's not necessarily its full design. Okay.
Do you take in consideration, let's say if it's a storm or something coming and it's gonna rain for like a day or two?
Do I take consideration? Yeah, I don't go to work. But I will say this to you, if we were having a drought, all you have to do is send me out to a job, start digging a hole, I guarantee it'll rain. Guarantee. Drilled and grounded mini piles are a foundation mechanism that is a small diameter, high strength steel shaft. And when I say small diameter, it's on the order of 4 inches to 9 or 10 inches in diameter. It has a wall thickness typically of a 1/2 inch thick. And the steel has a yield strength of 80 KSI. Okay? And we use those a lot in karst topography, because we will drill through the sinkhole and down into competent rock, and we will bond that steel casing to competent rock and transfer the loads for the structure all the way through the soft soils and down into competent rock. But all the load is taken typically in side friction. It's not in bearing, because the shaft is so small. You don't get a whole lot of bearing capacity, okay? But you can get a lot of bearing capacity in a 4-inch hole that's 30 feet long by just keeping track of the side friction that you have between the cement ground and the rock, okay? And those are typically put in with drill rigs, and we can put these in new construction, we can put them in an old construction. What you happen to see for me is this is a typical drill for us, because we are typically drilling inside of structures, inside of low overhead. I've taken that drill already inside of a kiln that makes bricks, and had to use 2.5 foot long drill steel to drill holes 200 feet deep. So it has the capability to do something completely different than the helical pot. These happen to be on a building in Murphy, North Carolina that had a huge sewer that went underneath it, and the sewer broke, and the building was kind of standing there in the air, and we threw rock in the hole, and then got on and started to underpin each box. Helical piles wouldn't work because I just threw rock in there. I had to get, or stone in there, I had to get 2 rock to be able to support it. And grouting is really high tech. It's bags of cement mixed with 5 gallons of water and an additive. That grout will have a 28-day compressive strength of 7,000 to 8,000 psi. In 24 hours, it's 3,000 psi. Different animal for a different reason. Different costs, I might add also. We did take some of the helical pile technology, however, and utilize it with the drilled and grouted pile. This is a typical shaft, a 1 3/4 round corner shaft, and that's a standard underpinning bracket. And I also think of all the years I've ever done this, I've never seen a poured foundation on a building that was that clean and that square. I want you to look at that. I've never seen that except on that place. Boom. We didn't touch that footing. That was the way it was. I showed you in that initial picture about placing the grout pipes. This is a residential situation where we had to use a combination of helical piles to support the structure, raise the structure, and then we had to grout all the soils that were underneath the slab. You can see where the slab had failed due to the settlement. What we've done here is we have placed our grout pipes in, our low pressure grout pipes in on a 4 to 5 foot center spacing, down to firm materials, and we will pull those pipes out and inject gravity will pull them out. Again, typical types of cracks. That crack there, I wanted to put it in there and point it out to you because I said to you before, a typical settlement crack is going to be a 45 degree from the building. That one's not 45 degrees. But it is a settlement crack because the crack in the floor went right across there, the back of the building fell apart right there. That's why it didn't go off at 45 degrees, I don't know. It didn't. So there's always a corollary in our business. One of your customers asks if you need to do some grouting in their garage or in their house or something like that, that's what you're going to end up seeing. That's the process.
And is that one there about $3,000, you said?
This one here, the grouting was roughly $3,000 and the piles on the outside were probably double that. So you're looking at a $10,000 or $15,000 fix here in that particular house. And just so you know, that house was under construction. It wasn't already there. There wasn't anybody living in it. It was already under construction. And the reason it happened, this is another example of what I was saying before. Look at the lay of the land and try to figure out what's going on. This happened because after the house was built, or while it was being built, they dug a big excavation out beside it and they buried those big, I call them tin whistles. It's corrugated metal pipes that they use to control drainage runoff, to store it for a while before they let it go on down the creek. Put it down right beside it, and the excavation was on the order of 15, 20 feet deep. And it was filled a whole lot right next to it. That movement on all that construction is what triggered all of that.
What kind of warranty do you provide?
Sometimes, depending on the situation, I'll give them a taillight warning. When you don't see my taillight, the warranty's over. All kidding aside, you can give a warranty for duration. I mean, if you truly are spending the money and you want it done right and you're willing to do that, I'll give you the life of the structure transferable warranty. Okay. But other people, well, I want you to come in here and just fill that void, don't treat those soils. Well, you get my taillight warranty for that. Okay. Yes.
One other question, you know, as inspectors, you know, we all kind of grapple with the idea of when do you really raise the alarm on cracks? And I know that there's a lot of different opinions about that, but for me, it's kind of the width of the crack. Are we looking at, displacement? Are we looking at rotation? Are we looking at, you know, what is the alarm bell for you to say that this is an actionable item?
The alarm bell for me takes a lot of things. One, if I see a crack, this is one alarm bell that runs off at you right away. If you see a crack, and it might be fairly large, it might not be that large, but if you see a toe, what I call a toe kick, where it's moved, it's rotated, and that raises an alarm for me. Because I then start looking to see, why did it rotate? If it's just a crack, and it's there, and it might even be a wide crack. I don't know, typically shrinkage cracks aren't very wide. So the wider the crack, that's an alarm bell. Shrinkage doesn't typically do that. You might see shrinkage cracks going across the floor, particularly in the residential marketplace. And it happens because they got the concrete too wet when they placed it, and or they didn't, and the slab's too wide, too big, they needed a control joint in it to take care of all of that. All those reasons you get.
And of course, the age is loud on that.
Exactly, that's the other thing I was going to get to. If I walk into a house that was built in 1980, and I see that there's a crack on the floor, and where might I find that crack? I might find that crack at the corner where the garage door is. You'll find out a lot in houses that old. I look at that, and if that crack is dirty, old and dirty, then that crack has been there for a long time.
Right, I
It
look
didn't
at the
move
edges
it.
also too, are the edges sharp, are they dulled out?
Yeah, you got it. It's that kind of thing. In this kind of an example, if you pulled the floor up, the carpet up of a house that was under construction, and you saw that crack, that's a little crack. There's something going on. What is it? Okay? That also manifests itself in the other things that I showed you. If you follow that crack over to that wall, and now you see something on that wall, something's going on. Okay?
Do you tap the concrete with something to see if it sounds hollow, or do you have tools to determine if there's a pocket there?
I've never been very successful in tapping on the floor and truly getting the kind of information I need. If I see some things that are happening, like we did here, we made them take the carpet out. Take the carpet out and see what it looks like. And then, on a garage as an example, I'll walk into a garage and I'll look at it and I'll say, I'd like to come back here and drill a few holes in your floor. I won't charge you for that. I just want to drill some holes, see how good the soil is underneath it, how much of a void there is, and I can give you a better price. Okay? It's the engineer in me that says, I want to get as much good information as I can to give you the best solution that I can. I give you the best solution, I also give you the best price because I have good data to make a decision with. If I don't have the data, then, which happens to me a lot, I'm sure it probably happens to you guys, it happens to me a lot, then I revert to experience. You know, I've seen this before, I can pretty much tell that this particular garage is going to take this many cubic feet of ground, it's going to be a void that looks like this, and here's the price. Sometimes knowledge isn't good though, because you know too much. Okay, you don't get that job, but be that as it may, it's the way life is.
If you quote the job, do you ever have to change the quote or something because you have to change the depth of here?
Now, typically, what I would do on all of my proposals is I will give my customer two things. One, I will give them a price to install X number of helical piles, X feet deep. If they go deeper than that, then the price is this much per foot. If, and it's not $100 a foot, I might add, whoever I told you, it's whatever the price of the material is plus the nominal markup for installation. But anyway, the other thing I give them is here's how much grout I expect to have happen, and I'm going to give you a price to put up to that amount of grout. And if it goes over, I'm going to charge you X dollars a cubic foot. Okay? That way they know going in. And as I'm going along in the job, if I put the first pile in, and it was supposed to go 20 feet and it goes 50, whoop, stop, let's go talk to this customer, because they got a big problem. You got something that I didn't even see coming. Okay, there's something else going on here, so they need to know this right away. You just don't go trucking down at the end of this thing and show them a bill later on, because that's foolish. Number one, you probably won't get paid. And number two, they would really be pissed off, I would. So you treat them the way you want to be treated. Yes, sir.
What's the trade-off in just cutting out the slab like that one there and dowel rotting, re-pour, put in compacted layered soils underneath?
Well, the compacted layers of soil is a problem because it went so deep. Okay, so what we did here, and I think they actually did take that portion of slab out later, but we grounded all the soils to depth. Remember the first cartoon I showed you where I had something down at depth? If I put, and it's the sponge analogy, if I only compacted the top 5 feet of this dirt and there was 10 feet of it that was soft and messed up, I just added more weight to the sponge, didn't I? And all that work that I just did isn't going to work, it's going to settle. So what we did here is we grounded all the soils so that I treated the soils, not going to have a settlement problem anymore. They had to make a decision about whether they wanted to route that joint and seal it with epoxy or something, or whether they wanted to take the slab out. I think in this case they took that portion of the slab out. Those slabs in that particular structure all floated up against the wall, so they were able to take them out.
What would be a rule of thumb cost for doing that?
To take the slab out and put it back in?
Yeah.
Again, that's a function of size and all the problems that go along with it, but if I would tell you to take out an existing slab and put another existing slab back in, just the slab, it's probably $18 to $20 a square foot.
Does that include soil addition?
No, the grouting would be, the grouting is that typical number I gave you for roughly 100 cubic feet of grouting. The number of poles right there is probably an order of $3,000, about a day's worth of work. And then the slab would be in addition to that.
You just cut that metal off at the bottom of the slab.
I'm sorry?
You cut the metal off at the bottom of the slab. You gotta pull them out.
I'm not sure I understand. You're talking about these pipes? Those are our ground injection pipes. And we put those in and drove them down to firm material. And now when I go to grout the soil and fill the voids, I will hook onto each one of those pipes individually and I will inject grout as I take that pipe out of the ground. And when I'm done, that hole that's right there is patched with a non-shrink grout. So yeah, those are gone.
If you were going to remove the slab anyway, would you not just remove the slab and try to compact?
Well, that's what he said.
That's what I was just saying. If the situation was that the slab moved because you only had a foot of dirt, and that's not typically the case, that was soft, take the slab out, take a foot of dirt out, put the slab back in, it's cheaper than anything we can do, because I can't really effectively improve the soil when it's only a foot from the ground surface. Another thing you need to understand, grout works like I do. It always takes the path of least resistance. Okay? And we call it pressure grouting for a reason. We have to develop enough pressure to get the grout to go out into the soil and fill the problems. Okay? And since grout works like I do, if I can't build that pressure, it just follows the path of least resistance. And it's been my experience when you only have a foot of material and it's near the surface, and you try to grout that, all the grout does is come out the end of the pipe and right up to the ground surface and hadn't done a thing for you. Okay? So you're not going to grout that. You're talking about stuff that you're grouting 3 to 5 to 15 to hundreds of feet below the ground surface. Okay? Real shallow stuff, you're not going to grout that. And the other thing I wanted to point out here too, you asked me about pressures. While we're grouting, we are also monitoring to see if things are moving. That right there is a laser. And we'll mount rod eyes on the walls and on the floors so that we have it going, and as we're grouting, we don't want to move anything. So we'll monitor that. Here's another thing too for you guys I just thought of, I don't have it in this presentation. there's a device out there now, I call it a water level. I think they call it the smart level. You can probably find it on the internet, but it's basically a reservoir of water with a plastic tube, and you can use that, set that down. You can see how elevations change in your structure. If you wanted to monitor to see if this thing really settled, and you can't really tell because you're not walking downhill, and sometimes it's easy to tell if you're walking downhill. Other times you can't necessarily tell for whatever reason. There's devices out there that are real simple to use, they're very inexpensive, and you can use them to monitor levels. It's all relative, it's not going to tell you that that's 100 feet mean sea level, but in relationship to that position right there, it's either lower or higher than that position right there. Yes. So I would encourage you guys to look into that. If you ever run into that situation, that would help you make that decision whether this has happened or not. Right? Yes.
A lot of builders have a 10-year foundation warranty. Do those really pay for this stuff, or?
You know, I don't know. And I'm being truthful with you, I don't know. I can tell you this, that way back when, insurance companies used to pay for fixing those foundations that settled and all the things that went along with it. And if you paid attention now in recent times, they avoid that like the plague. Why is that? Because it's easy to script the foundation because nobody sees it. Nobody really wants to pay for that because it doesn't add any value to the structure. At the end of the day, when you want to sell it for more, everybody wants to put their money in the architecture and fancy. So I don't know. I guess I would say to you, I would read what the warranty document says. For my 10 years, what am I getting? What am I truly getting? If it's something as simple and straightforward as if you get a half an inch of movement, we'll fix it. We'll raise it back up. We'll do whatever it takes to fix it. I doubt that it says it. So I guess my answer would be is you have to read the documents. I don't know. If I saw one, I could tell you whether I thought it was worthwhile buying or not. But I don't know.
So you're not doing insurance companies?
The insurance company avoids settlement claims like it's going out of style. If you go back and look at your homeowner's policy, anyone that challenge any of you, I don't care how old it is or how new it is, they're not going to cover settlements. And they even get more stringent. Anything that might cause settlement, they don't want to cover. So it's because it's such a big problem, the insurance company don't want to pay for it. I was saying, we put marks on the wall and monitor what we're doing. It's just simple, straightforward engineering. That's it for me. I don't know how much time I've taken. Have you got any questions? Yes, Mike.
I was just gonna, Dennis, I was just gonna tell you, you might also mention, this has nothing to do with what we do, but also another part of your business is pipe abandonment, filling around Atlanta, and well, really all over the country, but I know you'll do a lot of that.
I didn't get into, I tried to keep everything that I do based towards you guys. Our whole corporate, we do a lot, as he said, we do a lot of pipe abandonment grouting. A few years ago, we grouted 12.5 miles of gas line in 30 work days for Atlanta Gas Light. We put in 6,800 yards of cellular grout in 30 days. We're working on Georgia 400, 285 interchange. We're working for the general contractors there, abandoning pipes that run underneath structures and underneath 400 and 285 for abandonment purposes. And we're using a lot of the cellular grout to do that. To give you an example, I brought a couple of examples with me. Here's regular cement grout. You'll see it has a unit weight of 115. I also brought a sample of the cellular grout that we use. This one happens to be 36 pounds per cubic foot. You can see the difference and you can see how strong it is. If you want to come up and look at that, you're welcome to. is something, that particular material is what we're using to ground pipelines, sewer lines, and water lines. And for one reason, very simply, we can pump it for very long distances because it's so light. Yes, sir.
Two questions, sorry. CMU unmortared, big tall walls that are just off of Barrett Parkway, and I had a 30-foot wall 15 feet off the back. It had pin piles in it. They had the downspout drains from the roof electronically monitored. Obviously, it was an important thing. And there's one right over here, just on this development. So could you just briefly discuss those non-mortared CMU walls, how they work, and failures? Second thing is carbon strapping on block walls. We're seeing that a lot. I hear it's great. Is it good? Is it bad? What is it?
Let me address the first question first. You guys hear the question? The first question about what I call modular block walls. Modular block walls, just to give you a little history, are an offshoot of what started out years ago as what the reinforced earth wall company does. Is anybody here familiar with reinforced earth? Yes, no? Reinforced earth is a mechanism where there's a lot of those reinforced earth walls all around Atlanta, along the DOT right-of-ways, etc. And they are a mechanically stabilized embankment. They are designed so that the soil holds itself up like a retaining wall. And the facing is primarily just for architectural purposes. There is some nominal load on it at the face, but it's not designed, that facing is not designed to take lateral loads. Okay? The modular block walls that we see now being built are very nice because they're smaller in size and people can grab a hold of them and build them. And they're easy to build. Okay? And the rule of thumb is you're designing a wall that will hold itself up without putting any load on the face. At about 4 feet in height, a modular block wall with those little 16-inch long, 8-inch tall blocks, at about 4 feet in height now has to start being reinforced. And you'll find geogrids that will come with those structures. And I personally prefer to use gravel to design those structures as opposed to the normal soils that are out there for two reasons. One, it gives it better drainage. And two, it has a higher angle of internal friction, so it's stronger and it will hold itself up better. Okay? I had to replace modular block walls at my house because they didn't do that. And when I replaced them, I put stone and geogrids in it. So when you see that wall that's 30, 40, 50 feet tall, I'd want to know if that was designed, first of all. There are engineering companies around town that design those kind of walls, and there will be a specific design.
It has to be engineered. There's a bunch of houses sitting on top of it.
That's right. Now, that's another problem. Let me get this to you first. The length of those straps, as a rule of thumb, is going to be equal to the height of the wall. So if the wall's 30 feet tall, you should find those straps getting back there 30 feet. If not, they need at least to be 80% of that distance. Okay? And most of the engineered walls around town are in fact designed that way. Okay? I personally have a problem building a structure, a house as an example, on top of, directly on top of a mechanically stabilized embankment like that. Because there are some settlement issues involved. Okay? If the compaction wasn't right, it's no different than any other, but every time I've ever found a building, no matter how much they tried to engineer it, if they got the foundation sitting on the modular straps, there's typically a settlement issue. The magnitude of it depends on how well the construction of the wall was.
Which is why they're actually monitoring the roof water electronically.
Yes.
And built concrete shafts down to the bottom.
Yes. If they put concrete shafts on the structure, on the homes, they've bypassed the problem. They've designed it to be a bridge that will bridge over all of that mechanically stabilized soil. Okay? And you typically should not have a problem with the structure if they've done that. Okay?